Prepare to embark on an extraordinary cosmic journey as we delve into the depths of the universe and uncover the mesmerizing secrets of the Ant Nebula. Brace yourself for a visual feast as we witness the birth and demise of a celestial giant, unveiling a breathtaking spectacle that challenges our perception of space and time. Get ready to witness the Ant Nebula like never before as we venture into the realms of the unknown, where science fiction meets undeniable cosmic reality. The Ant Nebula, also known as Menzel 3 or ENS 3, is a stunning and enigmatic planetary nebula located in the southern constellation of Norma. This celestial beauty derives its name from its striking resemblance to the head and body of an ant when observed in certain wavelengths of light. The Ant Nebula is formed from the outer layers of a dying star that has shed its outer shell, revealing a complex structure of gas and dust illuminated by the intense ultraviolet radiation emitted by the central remnant, a white dwarf. The nebula's intricate and symmetrical shape, with elongated lobes and a bright equatorial ring, captivates astronomers and stargazers alike. The Ant Nebula has intense laser emissions coming from its core. When low to middleweight stars like our Sun approach the end of their life cycles, they eventually cast off their outer layers, leaving behind a dense white dwarf star. These outer layers became a massive cloud of dust and gas, which is characterized by bright colors and intricate patterns, known as a planetary nebula. Someday, our Sun will turn into such a nebula, one which could be viewed from light years away. This process, where a dying star gives rise to a massive cloud of dust, was already known to be incredibly beautiful and inspiring thanks to many images taken by Hubble. However, after viewing the famous Ant Nebula with the European Space Agency's ESA Herschel Space Observatory, a team of astronomers discovered an unusual laser emission that suggests that there is a double star system at the center of the nebula. The Ant Nebula, aka ENS 3, is a young bipolar planetary nebula located in the constellation Norma and takes its name from the twin lobes of gas and dust that resemble the head and body of an ant. In the past, this nebula's beautiful and intricate nature was imaged by the NASA/ESA Hubble Space Telescope. The new data obtained by Herschel also indicates that the Ant Nebula beams intense laser emissions from its core. In space, infrared laser emissions are detected at very different wavelengths and only under certain conditions, and only a few of these space lasers are known. Interestingly enough, it was astronomer Donald Menzel who first observed and classified the Ant Nebula in 1920, hence why it is officially known as Menzel 3 after him, who was one of the first to suggest that lasers could occur in the nebula. Characteristics: ENS 3 is radially expanding at a rate of about 50 kilometers/ and has its polar axis oriented at an angle of around 30 degrees from the plane of the sky. Lopez and Meeburn 1983. Meeburn and Walsh 1985. It is sometimes compared to the more extensively studied Butterfly Nebula, M2-9, and it is quite likely that both have a similar evolutionary history. They both have point-like bright nuclei, are narrow-waisted bipolar nebulae, and share surprisingly similar spatially dependent spectra. Because of their similarity, their differences are noteworthy. Their greatest difference is probably in their near-infrared emissions. ENS 3 has no trace of molecular hydrogen emission, whereas the M2-9 has prominent H2 emission lines in the near IR. The lack of H2 emissions from ENS 3 is unusual given the strong correlation between such emissions and bipolar structures of PN. Additionally, the polar lobes of ENS 3 are more mottled and rounded as compared to M2-9. Finally, ENS 3 is not known to evidence temporal variability in its polar lobes as is found in M2-9. Doyle et al. 2000. Smith 2003. The Herschel Space Observatory has detected laser light emissions from the nebula, specifically hydrogen recombination line laser emissions. This confirms the presence of a white dwarf with a binary companion at the heart of the nebula. The bizarre similarities of an ant. This bizarre nebula's similarities to an ant can be seen. The head is on the left, the thorax is to the right, and the legs are the emissions streaming out from the nebula. From its head to the end of the thorax, the Ant Nebula spans an entire light year across. At the center of the nebula is a star in the last throes of its life that is ejecting material into the surrounding space. In such an instance, it would be expected that the material would be flung in a spherical manner, but the cause of the odd symmetrical shape of the Ant Nebula is puzzling. The predominant theory is that the dying star is in a binary system with a companion at a distance comparable to that of the Earth and Sun, with the other star sweeping the material into the ant shape. Another theory suggests that the strong magnetic fields of the dying star are directing electrically charged gas moving at 1,000 kilometers, 600 miles, per second along the magnetic field lines to produce the ant. The Ant Nebula's central star is thought to be very similar to our own Sun, and because of this, astronomers are hopeful that by understanding what exactly is going on at the heart of Menzel 3, they may be able to predict what will become of the Sun, and indeed the Earth, in the distant future several billion years from now. As we bid adieu to this mesmerizing journey through the captivating Ant Nebula, we are left in awe of the cosmic artistry that adorns our vast universe. This celestial spectacle, with its ethereal beauty and intricate structure, serves as a reminder of the fleeting nature of existence and the transformative power of stellar evolution. In the depths of space, we witness the remnants of a dying star, reborn as a breathtaking nebula that transcends time and space. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.